All right, let's talk about a really powerful tool in the world of data, logistic regression. Now, you might have heard of its cousin, linear regression, but trust me, this one is built to answer a totally different and frankly, a way more common type of question. Okay, let's dive right in. So let's start with the main puzzle here. I mean, how do you predict something that isn't a number? Not how much, but a choice, an event, something that's either gonna happen or it's not. A simple yes or no. Well, that is exactly the problem logistic regression was built to solve.
And that's why we call it a different kind of prediction. We're not trying to guess a specific number like a price or a temperature. Nope. This is all about classifying things. Putting them into different buckets.
At its core, logistic regression is all about answering those binary this or that questions. Think about it. Will a customer click on an ad or not? Is this email spam or is it legit? Is the team going to win the game or not? See, it forces a decision, and that is just incredibly useful. So what are we really talking about here? Well, the key phrase you got to remember is categorical outcome. That's the whole game. It just means we're taking all the information we have, all those predictor variables, and using them to put something neatly into a box. Is it a yes box or a no box? That's it.
Okay, probably the best way to really get a handle on this is to compare it to something you might already know, linear regression. When you see them side by side, everything just kind of clicks into place.
It really all boils down to the question you're trying to answer, right? Linear regression, that answers how much. It gives you a number on a sliding scale, like the exact price of a house. But logistic regression, that answers which one. It gives you a category. Will a student pass or will they fail? One predicts an amount, the other predicts an outcome. That is the big, crucial difference. So you're probably wondering, okay, how does it actually do that? How does it magically predict a category instead of just another number? Well, the secret is in this really elegant bit of math that, lucky for us, is super easy to visualize. You remember with linear regression, right? We're basically just drawing a straight line through our data. The line goes up, it goes down, and you can pick any point on that line to get your prediction. It could just keep going forever in either direction.
But a straight line just doesn't work for a yes or no answer. It can't. We can't have a prediction that's kind of maybe-ish. We need a clear boundary, a clear decision. So we need a different shape. And here it is. This is the hero of our story, the S-curve. Some people call it a sigmoid function, but S-curve just sounds cooler. This curve, this shape, is the secret sauce. It's what makes the whole thing work, because its shape is absolutely perfect for dealing with probabilities. So here's the magic trick. The S-curve takes literally any value you throw at it, big, small, positive, negative, doesn't matter, and it squashes that value down so that the answer always lands somewhere between 0 and 1, always. And what's a number between 0 and 1? Yep, it's a probability. Okay, let's make this super real with a classic example. Imagine we want to predict if a student is going to pass their exam based on how many hours they studied. The only outcome we care about is pass or fail. That's it. So we take the number of hours they studied, we plug it into our fancy logistic regression model, and pop, out comes a number. Let's say for this student, it's 0.8. So what does that even mean? It's simple, really. It just means the model is predicting an 80% chance that the student will pass. Now, all we have to do is set a little rule, a threshold. Let's just say anything over 50%, we're going to call that a pass. And boom, just like that, we went from a simple piece of data, hours studied, to a real, concrete prediction. How cool is that? Okay, now that you know the secret behind it, you're going to start seeing this everywhere. Seriously. This isn't some abstract thing from a stats textbook. It's running behind the scenes in so many of the apps and websites you use every single day.
No, really, think about your day. Your email client deciding spam or not spam. A doctor's tool trying to figure out sick or not sick. An online store predicting, will this person buy this or not? Behind all of those simple yes or no decisions, there's a good chance it's logistic regression doing the heavy lifting, sorting the world into these super useful little categories. All right, so after all that, what's the one thing, the main takeaway you should really lock in? If you only remember one thing from all of this, please make it this. Just remember this one sentence. Linear predicts an amount, logistic predicts an outcome. That's it.
One gives you a number on a scale, the other gives you a choice. And once you really get that simple difference, you'll start to see just how much of our world, our digital world, is built on the simple but powerful act of predicting yes or no.